This is video 7.5. We're going to talk about dilations today. If you've ever gone to the eye doctor and had your pupils dilated, then you might have an idea of what a dilation is. So when they dilate your pupils, it's the same thing that happens if you go from being in a really dark room to walking outside where it's really bright and light outside. The hole in your eye that allows light to get in order for your brain to see an image gets bigger and smaller. So a dilation is going to be a change in size. This should sound kind of familiar of some things we've done with figures before, so let's go over that. We've already talked a little bit about transformations in a figure. The first one is a slide, so that if you have a triangle and then you move your triangle over, that's a slide. A turn is a rotation, and then a reflection is if you flip it. So those are the three general transformations we use. The other one is a dilation. So a dilation is going to be a transformation where you change the size of the figure but not the shape. So it's either making it bigger or smaller. So you can either enlarge it, reduce it, or keep it the same. Now, however much you make it bigger or smaller is called the scale factor. So if you have a scale factor that's more than 1, then it's going to get bigger. If your scale factor is less than 1, it's going to get smaller. So if it's a scale factor of a 1, then it stays the same. And then like a scale of 1 would stay the same. 1.5, it's going to get a little bit bigger. 0.7 would make it smaller. Now, every time you have a dilation, you're going to have a center of dilation. So you can find where that center is by taking the two shapes, the bigger one and the smaller one, lining up their vertices that are corresponding, and you draw a line through them. If there's a point of intersection, then there's been a dilation. So let me give you an example of what that looks like. So if I have two shapes, I'm going to draw lines through their corresponding vertices. That means that it's the vertice that is exactly the same one. So if you have triangle A, B, and C, then and is congruent to triangle D, E, F, then that corner A and corner E would have to be corresponding, and we could draw a line through them to find whether or not this is a dilation. So if they have a common intersection, they're a dilation, and if they don't, they do not. So let's say we have this triangle, and we have this smaller triangle, and we're wanting to know if it's a dilation, if the smaller one is related to the bigger one. So we're going to take the corresponding vertices, and we're going to draw lines through them. So like this would be 1, the middle ones would be 1, and then that one would be 1. Now my lines aren't exactly perfect just because it's really hard to do on PowerPoint to get your lines to match up perfectly, but you can see where they intersect. That would be the center of dilation, right? So let's say we have this triangle and we have this triangle. Now, if you're just looking at them, you would say, hey, they look exactly the same shape. They're just a different size. So let's see if it's a dilation or not. So I'm going to line up my same corners, all right? They do not have a common intersection, and so these two here would not be a dilation. These are, and these aren't. All right, so if you're going to dilate a figure, it's important to have a scale factor here. And so I'm going to give you a figure. It's got the sizes of the sides, and the corners are labeled. So we have triangle PQR. If we're wanting to dilate the figure by a factor of 0.4. So remember, if it is greater than 1, it's going to get bigger, and if it's smaller than 1, it's going to get smaller. What we're going to be doing is we're going to be drawing a triangle that is smaller than the given triangle by a factor of 0.4, which is going to be a little more than half smaller. But we want this point right here to be the center of dilation. So how do we do that? We are going to take each side and we're going to multiply it by 0.4 to find out what our new side is supposed to be. So we would take our 3.5 centimeters. We would multiply that by 0.4. That gives us a side of 1.4 centimeters. Then, so the side right here is going to be, I'm not actually going to measure it, but it would be right about there. Okay, so we would say that is 1.4. Let's take our 7 centimeters, multiply that by 0.4, and we're going to get 2.8 centimeters. So about right there. And then we would take our 7.5 and multiply that by 0.4 to get 3 centimeters, which is going to be this side right here. So that we have a dilation with a common point that it goes around the point of P. So whenever you're dilating a figure, you're going to take your scale factor, multiply it by the sides you have to get your new sides. When I have you do this in class, you'll need to have a ruler. I have a few that I can grab from the science lab, but if you have a ruler, go ahead and bring it with you to class tomorrow, because you'll be doing your dilations, doing actual measurements out on your ruler. All right, so what happens if you're using the origin of a coordinate plane as the center of your dilation? So we are going to have this figure. We're going to dilate it by a scale factor of 1.5, 1.5 being greater than 1, so we're actually going to get bigger. And we want to know what the vertices of the image are. So our original vertices of this triangle are going to be these. To find our new vertices, we're going to take each coordinate and multiply it by 1.5 to find out what our new vertices is. So we're going to take that 4 and we're going to multiply it by 1.5 and we'll get a new vertice there. We're going to multiply our 8 by 1.5 and get a new vertice there. So let's start with the 4. So 4 times 1.5 is going to give us 6. 8 times 1.5 is going to give us 12. 3 times 1.5 would give us 4.5. And 2 times 1.5 will give us 3. 5 times 1.5 gives us 7.5. And 2 times 1.5 gives us 3. So our new point is going to be at 612. It's going to correspond with A, so this would be A with a little hash mark there. Point B is going to be 4.5 and 3, and then point C is 7.5 and 3. So when we do this now, we can graph both of these. All right, so I'm going to graph my original first, and then we're going to graph the dilation, and then I'm going to show you how the lines go through the center of origin. So 4, 8 is right there. That's A. And then 3, 2, and 5, 2. So here's our triangle. Now my new one, I'm at 612. Don't actually have a 12, so I'm going to just put that up right there. 4.5 and 3. So here's my B. This is A. And then C is at 7.5 and 3. All right. So if I take my corresponding vertices, which are going to be my A and my A little dash here, my line's probably not going to be perfect because I don't have a ruler with me. But if I drew a line, it should come right to the center right here. There's the center of origin. That's where our lines overlap. We'll do a few more of these when you get to class. Go ahead and click on the link and do the quiz for your homework, and I will see you later.